All right. Welcome everyone to our virtual launch event today, Fuzzing Forward. We will probably wait maybe 30 more seconds, let some people join in. I can see there's still folks calling in, so that's great. So as a warm-up, if you don't mind, please open up the chat feature here in Zoom and let us know where you're calling in from today. I myself am here in Bonn, Germany, so in the west of Germany. My colleague Rita, who's behind the scenes and was doing all the hard work for this, is in Budapest. But yeah, we'd love to see. You can put it there in the chat function, just city, where you're calling in from. And again, we'll just give maybe a few more seconds as people are dialing in. Let's see here. Very good. We got some fellow Americans, someone from Georgia, Valencia, Spain, Switzerland. Wow, this is an international crew here. Abu Dhabi, Bonn as well. Some fellow Hungarians, Rita. Italy, awesome. Very cool. Well, thank you guys for that. Okay, so let's get started. First of all, welcome to Fuzzing Forward. This is our virtual launch event here at Code Intelligence, where we're announcing and releasing our revolutionary AI test agent that automates the discovery of vulnerabilities in your code. Code Intelligence, as a short introduction, we're a software company developing fuzz testing solutions with the goal of helping our clients ship secure code faster. Good evening to those in APAC. Thank you for joining late. Good afternoon to our European friends, and a great morning to those in the US. My name is Ty Brush. I will be your moderator for today. And we have an action-packed agenda. We're super excited to jump in. We're going to be hearing from some industry leaders, and then obviously you'll be getting a firsthand view at our new product, Spark. So let's take a look at the agenda. So we're going to start here with an introduction. That's what I'm doing now, just a few minutes. Then we will be moving to our CEO, Eric, to give our opening keynote and discussing some of the challenges that we're seeing facing the industry around software security. Then the most exciting moment, we're going to be giving you a live demo of our new AI test agent, Spark, that's being run by Hullet. And then we'll be moving to a panel discussion. We have two esteemed guests joining us, Sheikh and Christian. So we're very excited for this, and it'll be a fascinating, interactive discussion for all to attend. Lastly, we'll wrap up with our roadmap, and this will be done by our CTO, Nicholas, who will be giving a look into the future. So what is to come that we're going to be stacking on top of our AI test agent? Very exciting stuff there. So please do, if you can, stay on for the entire event today, and yeah, it should be interesting. And then we'll wrap up with a Q&A session as well as closing remarks. Okay, some quick housekeeping items here for you. So it looks like most of you found the chat feature. That's fantastic. Feel free to say hi. You can chat to other participants today, but just be advised, there is a feature that you can be sending messages to everyone or just certain panelists or something like that. So just, again, be advised with what you're putting in the chat. But we will not be monitoring the chat for questions. So please, please, please use the Q&A feature, which is also here in Zoom, to send in any questions you have throughout today's discussion. You have the ability to upvote these questions. So if there is something that you find to be relevant or you think it was a good question, please upvote that, and we will prioritize those to answer them live or at the very end in our Q&A session. Please take part in our polls and surveys. So we will try to keep it somewhat interactive. And during this, I'll go ahead and launch our first poll just so you all can see how that works. So yeah, we'll be launching a few polls here and there, and we would love for you to interact and vote. Throughout today's event, last housekeeping item, throughout today, our team will be putting in relevant links and topics into the chat feature around the topics that we're discussing at hand. So feel free to check those out in the chat feature as they come through. And I believe that does it for my housekeeping items. Awesome participation. Thank you. I'm seeing some of the votes come in here. I'll go ahead and end the poll. and share the results so we all can see it. And with that being said, Eric, I'll have you come in here, take a look at some of these results. From my perspective, we have an awesome wide-ranging group here. So some very familiar with fuzzing, some with no familiar at all. We hope to fix that today. But yeah, Eric, what are your thoughts?
I couldn't have said it better, Ty. So it seems like half of our participants are very familiar with it, but then we have a pretty good stretch across the other categories. So that's actually great for my opening keynote because we will be explaining fuzzing to a certain extent, but we do not want to hold you back too long from Khaled's live demo, which we all know is the key event of today. So I think I'll try to keep it short and brief. But first of all, from my side, very warm welcome. Can only basically echo what Ty said. It's great to have so many people from all across the globe dialed in. I saw Japan in there, I saw the US in there, quite a few European friends, partners, and colleagues. I did see Goa, India in there as well, which makes me a little bit jealous looking at the grayish sky here in Cologne. So I do hope and I do think it's a little bit nicer over there. Thank you for joining. Thank you for spending the time with us, and very much looking forward to the discussion, to the engagement today and after that. So, what will I be talking about today? We'll spend the first 10 to 15 minutes regarding fuzzing forward. Why are we here today? And what is basically the context and the purpose of us trying to overcome challenges in shaping the future of software testing? And let me maybe start by just throwing a very, very big number out there. So that's 9 trillion. That's 9 times thousands times 1 billion. This is a number that is obviously, it's so huge, it's almost impossible for me to fathom. And if you put that into comparison, you can compare it to, for example, the GDP of the leading nations of this world. And if you look at that, that would be number 3 after China and the US. But what do those 9 trillion stand for? That is the amount of damage that was caused last year globally by cybercrime. And obviously, talking about security testing, talking about cybersecurity, this is a topic that is close to everyone's heart who's joined today. And we'd like to dive a little bit deeper into what actually caused it and how it relates to today's event. After such a huge number, obviously there are a multitude of factors that contribute to such a big numbers, right? But I just want to leave you with 3 key ones that did resonate with me quite a bit and that for me provide a very, very, let's say, sound reasoning why we should actually start caring about cybersecurity and especially about securing our code now. First of all, 31% of those 9 trillion are actually caused by cybersecurity issues due to vulnerabilities in the code. So the code, the source code of the software is where it all starts. But bad news is that there's not just a finite number of code, but it actually continues to increase. So if you look at the last year, 125% more new code being created compared to the year before. So an exponential growth in volume of new code out there. You could say, well, it's more code, but does that necessarily make it harder to test or to say more insecure? Unfortunately, the tendency currently is that, yes, it's not only more, but the code that gets released only tends to contain more vulnerabilities than before. So 1,300% increase in vulnerabilities in new code compared to only 4 years ago. And this might seem a little bit far-fetched. You might think, well, that doesn't really concern me as an individual. At my company, we haven't really seen that many vulnerabilities. So why should I care? And I just want to basically point out one, let's say, very illustrative example of what this can entail. And some of us might still remember the largest IT outage in history, and that was the CrowdStrike incident last year, where basically global air traffic and a significant part of the critical infrastructure just came to standstill for almost 24 hours. And all that due to a vulnerability in the source code. And that is something that translates into different areas of our lives, of our businesses, of our careers. And what I just want to leave you with here in the first section is to say, cybersecurity is not a solved issue. Quite the opposite. And the quantity and complexity of code continue to increase exponentially. This is why we firmly believe that there is a need for new security testing strategy to not only keep up with the times as a company, but to really stay ahead of the curve and proactively, not just reactively, basically engage with the topic of code security and in order to make sure that our customers, our products, our company is safe and secure going forward. So you might ask yourself the question, Eric, yeah, that all makes sense, but honestly, this isn't exactly new. And aren't there any security testing approaches out there that actually help us address this? And yes, 100%. Of course there are, but for me, they always fall into typically two categories. They're either super easy to use, but they tend to stay at the surface. And typical SaaS static analysis, I think, tends to fall into that category. Or you have very thorough testing approaches, but they're typically very complex, require expertise and a lot of manual effort to implement. And for example, penetration testing, which can be done pretty late in the SDLC, but also fuzz testing, which fuzzing forward certainly does relate to, fall into that category. So when we want to understand a little bit more, also for the, let's say, I think it was 17% of people attending today who are not too familiar with fuzz testing, what is fuzz testing actually all about? And you might be familiar, or basically the type of fuzzing that you might remember might be, let's say, the old world definition, where you have a fuzzer who basically shoots random inputs at a system under test and tries to crash it. And what it looks like at the end of the day is this, right? You just have a million different, let's say, test inputs, and somewhere in there might be hiding one that actually gets to your system to crash. Then you know what happened, you can actually fix it. But to be very explicit, today what we are as code intelligence referring to is white box fuzz testing. That is a, let's say, new world approach to fuzz testing that doesn't just shoot random inputs at a system under test, but smartly generated ones. And there's a feedback loop in there using genetic algorithms that basically tracks where in the code a specific test input, let's say, landed and where it found its way. And based on that, feeds that back to the fuzzer to actually come up with the next input and thereby continuously adapt and improve the test inputs to, let's say, get the system to crash in a way that is as effective as possible. So this is what we understand at fuzzing, right? And there are certain benefits related to that fuzzing, because at the end of the day, there are three major ones that we'd like to point out. First one, fuzzing, and specifically white box fuzz testing, finds what other misses, because basically it doesn't just test the source code, but it tests the code while executing it. Thereby, it finds issues such as memory corruption, runtime bugs, and most of all, there are no false positives. So it really only flags real findings, therefore making, let's say, follow-ups, for example, and discussions a lot easier. Second, it thoroughly tests your software. By having those thousands of automatically generated test cases, it basically achieves something that humans would only be able to achieve with a lot of time in their hand. And by having a white box approach in place, you actually get concrete feedback on the code coverage, i.e., you know specifically which, let's say, paths in the code have been taken, which are left unexplored, and where you need to focus on to generate the most effective test. And last of all, it aids in root cause analysis. Why? Because it doesn't just tell you there is something wrong. It actually pinpoints exactly where in the code the bug is hidden and exactly what triggered it. You have the stack trace, you have the crashing input, you have the exact location, thereby remediating it just gets a lot easier by having all that information in place. And this is also where, if you look at the process end to end, from discovery to remediation of the bug, white box fuzz testing can make a huge difference. So hey, again, that sounds great. So why doesn't everyone use it? And how does it translate into practice? And to just give one real world example, we'd just like to point out, for example, the Heartbleed vulnerability. A vulnerability that actually had remained undetected in OpenSSL for more than 2 years. So it was difficult to find. Then it was eventually found, and when someone then started trying fuzzing for this type of vulnerability, it was determined that fuzzing can actually find this that had remained undetected for more than 2 years in only 5 seconds. And the stuff here on the right-hand side, which I'm sure you're following line by line right now, this is basically how Heartbleed is identified by fuzzing. How is that important and how does that link back to the original story? Because Heartbleed, that's the same type of vulnerability than the one that caused the CrowdStrike incident. So there you can see there is a real life application. A lot of damages could be avoided if fuzzing is to be applied at scale across different industries, across different companies. So why isn't everyone using it? I mean, that's, for me at least, kind of the logical question one asks oneself when hearing all of this. And what it comes down to, it is just a lot of effort, because most companies out there don't have the time and the budget to build up the expertise, to spend the time and manual effort on it, and to change their existing workflows and systems to incorporate fuzzing, right? And that's perfectly fine and understood. And what leads to that? So, well, we typically try to divide the testing process into 5 different steps, right? And what we typically take as a, let's say, good base for comparison is a code repository with 100,000 lines of code, which is not a lot, to be honest, right? If you look at a car, for example, that is launched these days, the software in a car typically contains 650 million lines of code. So 100,000 lines of code, that's not a lot. And if you were to actually test that manually, traditionally, you would need up to 1,000 hours to do that in a thorough manner. And what basically causes those 1,000 hours? So first of all, you need actually to be able to select the right targets. You need to know where to test, right? And for that, you need domain knowledge, i.e. you need to understand the structure and the intent of the code. And that's very easy if you're the one that built it yourself. But is that still the case these days? Who actually basically has the time to do that? In a lot of cases, it's code built by an outside party, by colleagues from a different department, by colleagues who have retired 10 years ago. So legacy code bases across businesses do tend to just increase and increase and increase. And thereby, to be able to identify the most likely attack vectors, you need to, let's say, upskill yourself, familiarize yourself with the code, which takes time. Then the second step, once you've known where to start and what to test, you actually need to manually create the test. And that in itself is probably the biggest effort in those 5 steps, because to do so, you actually need fuzzing expertise. You need to know how to build an effective test, and also, let's say, how to run it and how to, let's say, validate that it's actually as effective as it should be. So this costs time. And then to make sure that it actually runs in the build environment, that basically it really translates into a test that gains coverage and that is effective as it could be. Again, yet another step in the testing process that typically needs to be done manually. The good news is you then come to the first step, the 4th step, and that's the one where you need to define and vary the thousands of test inputs that you need to actually basically trigger the SUT to crash. And this is where open source fuzzing engines come in. So this is not new. This has been around for 10, 15, 20 years in some cases. And that is something that you can do based on open source materials out there. But that already saves you quite a bit of time. But the thing is, you don't need to just do that once for a code repository. You need to do that dozens, 100, and 1,000 times, because you don't need just one fuzz test. You need several. And thereby, you want to make sure that you actually merge all the coverage information, all the findings, any outputs from those tests in one, let's say, joint solution, right? Because you don't want to have a manager, you want yourself just go through thousands of different test results. No, you want to have one overview. So merging the coverage and findings, this is something that takes additional time, especially if you want to make sure that you also want to triage and debug it properly. So for 100,000 lines of code, the pain point that prevents most companies from not applying this at scale is just the required manual effort. 1,000 hours, who has that time these days, and who actually basically wants to invest resources in doing so? So what are we here for? So at Code Intelligence, as Ty mentioned, we are a software startup focused on test automation, and not just about making, let's say, difficult processes more difficult, but our goal is to bring the power of advanced security testing into reach for all. Because I firmly believe that only something that can be implemented, that actually use on a daily basis, is something that makes an impact. There's no use of having a great technology that just sits there in some cupboard and is not being looked at, is not being used, and it just serves to tick a compliance checkbox, not to make an actual change in our daily lives. And this is where Code Intelligence comes in, and this is what we want to help our customers achieve on a daily basis. How do we do that? We do that by fully automating all of those 5 steps. by combining elements from software testing, such as dynamic white box testing and static analysis, with AI components, i.e. large language models and genetic algorithms. And we basically put them into a continuous iteration that allows you to test those 100,000 lines of code that we mentioned before, not in 1,000 hours, but with one single command in your CLI. And this is what we're here to show you today, how that works, how the interplay of those different steps of the process, the automation of them actually works, and how that looks like in practice. This is something that I do not only claim myself, that's obviously very easy to do, as you can all imagine, but even though we're only launching Spark, our AI test agent, today, we have already received A, some real-world accolades, but also B, created some real-world impact with Spark as part of our testing process, with a beta testing with our existing customers and partners to make sure that once we do launch it today, it's really up for the challenge and can be employed at scale. The first one, and we did basically release a press release about that roughly 2 weeks ago, our AI test agent is the first product worldwide that completely autonomously discovered a critical vulnerability in an open source library, specifically Wolf SSL. So we're working with the Wolf SSL team. They have acknowledged it, they have fixed it, they have released the fix. They're here today as part of, let's say, the participants. And this was for us the key proof that what we have developed here makes sense and makes a difference, because this was a vulnerability that had been there for some time and that basically hadn't been found despite it basically being tested, being fuzzed even for quite an extended period of time. But that's not a one-off. We have actually discovered more, which we're in the process of responsibly disclosing with the respective maintainers, and we'll be sharing more information on that. Right now, we can't, let's say, name any details because they still need to, let's say, fix and release the fix. Second one, a little bit less technical, similarly as impressive in my opinion. So just 2 weeks ago, we were awarded the German AI Award for our AI test agent for the solution that we've built. And as you can see here, some might know the guy on the left-hand side. That's our Vice Chancellor, Robert Habeck, who basically presented us with the award. And we were super happy to receive it because this for us signals that it's, hey, it's a great technology, but the value of the technology is also something that is acknowledged and that is basically rewarded by the broader public. And then the third one, as part of the testing of open source libraries, which we typically use OSS Fuzz libraries for, we were able to, on average, achieve autonomously, again, more than 30% of code coverage increases in those libraries by just typing one single command in our CLI, by having the tool run completely autonomously for an hour, and then basically increasing coverage, basically code coverages that had been around for years because those repositories had been tested before by more than 30% on average. So for me, quite a few impressive feats that we're super happy to share with all of you. But obviously, right now we're launching it today, so we're even more excited to see what it can do once officially being out in the wild, out being used, and basically being employed at scale. So to recap, 100,000 lines of code really is a thing of the past, because what happens to those 1,000 hours of manual effort that you typically need? It gets reduced to one single command, and that is all that remains to be done to fully automate that entire process. But now, slides are very easy, right? Everyone can always put something on slide, but we do want to show you the code. We do want to show you how it looks in practice. So right now, I'm super happy to hand over to our CPO and co-founder, to Khaled, to show you in a live demo what I've been talking about, what I've been describing, and how Spark, our AI test agent, looks in action. Khaled, over to you.
Thanks a lot, Eric. Hi, everyone. Really excited to show you Spark today. So, as Eric mentioned, so in this live demo, we will see how Spark work on a real-world code base. And the project that we are going to use here is zlib.yaml, which is an open source library written in C for parsing and emitting YAML files. And it's a code base that I'm not familiar with. And this represents a scenario we often see in the industry where the security teams responsible for fuzz testing are sort of different from the engineering or development team. So they don't have the detailed domain knowledge that's required to just quickly start writing fuzz tests for this repository. And before we see Spark in action, or before we see how Spark can actually handle this case, let's spend a few moments discussing what I would have to do if I was to manually fuzz this project. So as Eric mentioned, so the first thing that I would ask myself is would be where to start. So what are the important functions, the important entry points, APIs to focus on or to tackle in this case. And so I can, for example, have a look at the documentation here. I can read the docs. I can talk to the development team, or I can even have a look here at the code. So we see, for example, in the source file, in this repository, that there are several functions defined. And so I can have a look at those functions, try to make sense of what they do in order to basically pick the best functions or candidates that I would focus on. And this is a sort of small code base of roughly 6,000 lines of code. But now imagine you have a large code base with millions of lines of code and thousands of functions. So you can imagine that this is quite consuming, and this step can easily take days or even weeks. And the next step, after I have identified my my main function that I want to focus on, that question becomes, for example, if I have a look at this one, so the question becomes, how should I write a test or a fuzz test for this function? And for that, in order for me to do that, I would need to understand, for example, the different workflows in which this function can be used, any setup or initialization that needs to happen before I can actually call this function to set up the correct context, and also where should I provide the fuzzer generated data. So all these questions require deep domain knowledge about the code base, and you can also see why this can be very time consuming. And so these two steps are usually the main barriers or obstacles that you need to tackle in order to have a suite of fuzz tests that you can actually run and try to optimize code coverage. And with Spark, our goal is to automate this entire process. So Spark is integrated into our main product, CI Fuzz. So let me bring my terminal, and it's available as a command for CI Fuzz. So to invoke Spark on this code base, all I need to do is to call CI Fuzz Spark, and I give it a goal to reach. So a code coverage goal. So what I'm saying here, Spark, please go have a look and at the code base, generate the test until you reach 75% code coverage. So let's let it run and see how Spark handles this case. So if I started, first Spark scans the code base to identify the most important functions to test. And these functions are characterized based on the likelihood of or the impact, the expected impact. So this includes things like the expected code coverage and the likelihood of triggering a bug. And in this case, we found this 59 function that we can fuzz. Spark picked the best one, created a fuzz test, ran the fuzz test for a certain amount of time, and here is only 10 seconds for demo purposes. And this first one reached 66% code coverage, and it triggered a finding. And then, based on this information and the code coverage that collected in the first step, then Spark selects the next best candidates, and the process continues. Create a fuzz test, run them, and so you would see here that the code coverage is steadily increasing until we reach our goal. And to make sure that we generate high quality fuzz tests, so that Spark generates high quality fuzz tests, we employ advanced techniques to make sure that we get the best answer of the LLM, but we also perform verification or refinement steps to make sure that the fuzz tests that we get are of a high quality, that we can build and run and they gain code coverage. And if this is not the case, refine them, optimize them automatically until they do. And so here, Spark was faster than me and finished the job and reached the target code coverage. And so here we see a summary of the results. So Spark, as I mentioned, reached the goal code coverage of 75%. To do so, it needs to generate 3 fuzz tests, and it executed, or it generates 2,500 unique test cases. And these are test cases that triggers unique code coverage or unique behaviors in your program. And it detected 1 finding. And just remember here, so all I had to do to reach these results is run Spark on the code base. And this is here would be a good opportunity just to highlight two of the main benefits of white box fuzz testing. So the first thing is that you get actionable results, meaning that for each finding that we report or that fuzzing finds, you get here the exact location where it happened in the source code. So you can directly jump into that location and see, for example, this finding was caused by this wrong use of memcopy. You also get the complete stack trace and the exact input that triggers this vulnerability. And these information are valuable, are very important to just easily reproduce this finding by, for example, starting a debugging session. And this enables you to quickly understand the root cause and then come up with a fix easy. And so this is the first benefit you get. The second benefit is that you get detailed code coverage insight into the code. So you know exactly the lines of code that you have tested or that you have not yet tested. So, and you can even show it here in your IDE very easily. So if I can click here on watch, you see we get in green these lines of code that we covered and that we have not covered. And then the same goes here. So you know exactly what you tested and what you have not yet tested. And so just to make it also this clear, so all what I need to do was to run Spark on this code base. And this is, by the way, the same way or the same manner how we was identified the Wolf SSL vulnerability. So we just let Spark run there. It created the fuzz test, and one of them triggered this vulnerability. So this is mainly what we wanted to show you here in the demo today.
This is great, Khaled. Thank you for this. Before you leave your IDE there is one question that I think you could probably show us live. Someone has asked, how can you see what the fuzz test, or how can you see the fuzz test created by Spark, and can you work with that? So can you see the output from Spark?
Yes, certainly. So the fuzz tests that we generate, so that's that the Spark generate, as you can see here, are persisted, so that you can then, starting from this point, have a look at them and refine them as you wish. So, for example, we can have a look at the first fuzz test that Spark generated here. And so here, as I mentioned, so this is then persisted. You can have a look, you can refine, improve, etc. And then this is also, let me take this opportunity just to go through this fuzz test a little bit. So we see that it's quite a bit of code that Spark generated automatically. And so while we see here at some point that our target function is called, so you can see that Spark managed to create the initialization code that's needed for this function at the end. Also do the proper cleanup, and these are the steps that are necessary to have realistic and high quality fuzz tests.
Fantastic. Thank you for that. All right, I will go ahead and share again, and I think you'll give us a quick wrap up.
Exactly. So what did we see in the live demo? So what we saw is that in roughly or even less than 2 minutes with a single command, Spark generated or set or was able to accomplish our target goal of testing or fuzzing the project and achieving a minimum of 75% code coverage. This time it was exactly 75, but this varies. Sometimes you get 80, sometimes you get 76. And this is the main part for me here, is that it automatically generated, built, validated, and ran 3 individual fuzz tests and generated automatically roughly 2,500 unique test cases. And yeah, it uncovered 1 bug, and hopefully this is the only existing bug in this project. So this gives us a summary of what Spark achieved in these 2 minutes.
Thank you. Thank you, Khaled. All right. So obviously super exciting. And as Eric mentioned in the beginning, with today's event, Spark is officially commercially available. So it is available to the broader market, and we're just super proud of the team and what they've created and developed, and obviously bringing that for you all today. So before we jump into the panel discussion here, there are quite a few questions coming in through the Q&A. So as mentioned in the beginning, please do upvote the questions that you find to be the most relevant, or if someone has asked the question that you're going to ask as well. We will have Khaled and the team, we can answer some of those individually in text, but we will also be having a Q&A section where we will take some of these questions and answer them live with our team. Before we jump into the panel, we're going to launch our next poll. So super interested to hear. I think this is obviously very relevant with today's news. I think everyone woke up, well, yesterday, but waking up today and hearing about all of the drama going on with LLMs and who's creating them. So it's certainly a relevant time, but interested to hear, does your company have LLMs available or approved to be used internally, or perhaps not yet? So just give a few more seconds to answer this. And in the meantime, I would say our panelists, Sheikh and Christian and Khaled, you guys can bring up your cameras. That would be great. All right, and we'll end the poll. And let's share the results. So yeah, this is, I would say it's in line with, Khaled, what you and I have been at least talking to customers and prospects. We kind of hear it's a split. So 50-50 chance. Some people have them already. Some people are thinking about them, but maybe don't know how to necessarily get them approved. But yeah, I think that's, I don't know, Khaled, do you have any thoughts on that? Surprised by that, or in line with your expectations?
It was basically, as you mentioned, so similar to what we see at customers, and then ones that we talk with, and they want to have their own LM. So the discussion is always, should we use like an open source one that we host ourselves, or should we trust a third party provider like Azure with that?
Right. Well, and there are quite a few questions coming in about which LLMs do we use, which ones should we promote. So we will we'll handle some of those questions again in the Q&A section after Nicholas's section. Okay, so without further ado, we can jump into the panel discussion today. So thank you, Eric and Khaled, obviously, for the fascinating stuff that you kicked us off with today. But we're now going to focus and shift our focus to hearing from some industry experts and leaders in this space. Our panelists today will explore the impact of artificial intelligence and large language models on the evolution of fuzzing. We'll offer some insights into some of the current challenges and potential solutions that are out there. But first, let me go ahead and introduce our panelists. Our first panelist is Dr. Sheikh Mahbub Habib, who's the head of cybersecurity and privacy innovation at Continental. Sheikh is focused on driving strategic initiatives that bridge the cutting-edge technologies with tangible business value for Continental. Next, we have Christian Holler, a principal security engineer at Mozilla. Christian is a principal engineer and a tech lead for Firefox, focusing on security and privacy. As part of his work, he leads their fuzzing and other dynamic and static analysis efforts at Mozilla to protect millions of their users. And last, obviously, you've met Khaled already, but Dr. Khaled Yaktin, Chief Product Officer and co-founder at Code Intelligence, is our third panelist. Khaled has spent nearly a decade on the topic of fuzzing and building world-class products around that, of which you saw one today, Spark. Okay, so with that being said, gentlemen, thank you for joining. Super excited to have this conversation, and let's jump into our first topic. So I think if it's okay, Christian, I'll start with you, and perhaps would you kick us off with what you're seeing in the field today? Where does fuzzing fit into, or fuzz testing fit into, an enterprise organization's high-level security goals?
Gladly. Yeah. So I would say fuzzing has become an elementary part of the security lifecycle nowadays. There's just certain properties that make fuzzing like really attractive. Khaled already mentioned actionable results. I think that is one of the key aspects. Engineers really like to have test cases that they can work with, that they can debug. And we have internal data that actually shows that fuzzing test cases, or bugs that have fuzzing test cases, have a very short fix time and a very high fix rate. And I attribute that to the actionability of the report. But I also want to say it's not just security. Fuzzing can also be used for reliability purposes, and that also plays a big role for Firefox. We don't only want our product to be secure, but we also want it to be reliable. We don't want crashes, and fuzzing can also help to identify reliability issues.
Sheikh, any thoughts on that? How does this compare to what you're seeing? And we want today to be interactive, so please, gentlemen, feel free to jump in and give your thoughts as we go.
Yeah. So I mean, following up from Christian from Mozilla, I would like to focus on the automotive context or automotive domain. When I started working with in Continental with automotive software back then, I would say 2017, 2018. Still, I mean, the fuzzing was readily available. I mean, the open source packages were available to use, and many of the IT industries, tech giants were using them and finding very good results. But back then, it was hardly used in automotive domain. There are definitely a lot of challenges. We'll be talking about that as well. I'm not going to deep dive into that now. Compared to that, to now, fast forward to 2025, it's amazing to see that all automotive players, suppliers, and OEMs and other embedded software developers are heavily using coverage guided fuzzing, for example, gray box or white box fuzzing, to find software defects and vulnerabilities. As Christian said that we can also detect reliability issues, crashes in software, and it is using for both also in the automotive domain. And definitely it speeded up a bit the usage of fuzzing into the automotive due to ISO 21434 standardization and UNECE compliance, which I mean, in the standard of ISO 21434, it's directly mentioned fuzzing as a testing mechanism that to be used or recommended to be used to find defects and vulnerabilities throughout the vehicle lifecycle, the vehicle software lifecycle. So I see we catch up with IT industry, but we have a lot to do.
Certainly, and I think I get anxiety every time Eric talks about hundreds of millions of lines of code involved in running our vehicles of today that are on the road. This idea of software-defined vehicles. So I think it makes a lot of sense that you do implore white box fuzz testing or this type of coverage guided fuzz testing to find these vulnerabilities before they end up in production. Okay, so Assuming, Christian, I'll probably come back to you here. Assuming fuzz testing is adopted as one of the adopted measures to find security vulnerabilities, I think you mentioned one of the main benefits you get is a short fix time. So you get pinpointed the exact line of code. You're able to implement the fix quite quickly. Do you face any divide in the responsibility between who is responsible for fuzz testing in an organization like yours? So, for example, is it on the security side of the house? Is it on the engineering side of the house? And is there friction in that, or maybe walk us through your thoughts?
So at Mozilla, we actually have very little to no friction regarding that topic. I believe that's because security is already sort of part of our DNA. The manifesto, the Mozilla manifesto, basically mandates security, and really every developer at our company wants to help the product also more secure. So everyone sees it as their task to help securing, and there's just a lot of collaboration going on between security and engineering. But I can see that in other setups and other companies, in particular with fuzz testing, you can have this friction. Fuzz testing has this property that it can be overwhelming at first when it's being deployed, because it can produce a large amount of bugs. And you just need to collaborate to ensure that you have the right resources allocated to deal with these bugs, so the engineers don't feel overloaded and get defensive from that. And also to make sure that you have your engineers on board, that you're testing the right things, that the engineers actually see value in the testing that you're doing. So it's a management task as well to make sure that engineering and security come together here, best before starting to do fuzz testing, to have a good plan of like how to handle the results of that.
Khaled, how does that align with what you hear? I mean, I love the idea of collaboration. That's music to my ears when we're talking about security and engineering. But yeah, where do you see that? Do you echo Christian's point?
Yeah, totally. So this is something that we also see quite often in the industry, and so for me, like in an ideal world, developers would be able to write fuzz tests for their code, because they are the best people, experts to do this, because they do have the domain knowledge. They are the best to know all the edge cases, all the workflows that and the correct way that the code is supposed to be used in. But this is not always the case, and so I think Christian put it very well. So we need to have a collaborative mindset, and also sort of a mutual trust relationship between security and developers, because the last thing that you want is that developers have the impression that security people are just pinpointing what I did wrong, and telling me what I messed up, basically. And then you would get in this defensive mode, and then you start sort of downplaying some of the issues that they get reported, and so it's a lose-lose situation. What you also don't want to do is security people reporting bugs by fuzz testing because they use the software in the wrong manner, because this is not the way you're supposed to use it, for example. And this would also understandably create frustration on both sides. Yeah, so having a collaborative mindset so that both teams have or know or see that they work towards the same goal of having a secure and reliable software is a key ingredient here. But I would be also interested in Christian's viewpoint as well, because now you said it's such an integral part of your testing strategy. Was this the case at the beginning when you first started to introduce fuzzing into Mozilla?
So again, Mozilla is quite special here because basically all of the browser companies were adopting fuzzy very, very early, even earlier than the overall fuzzing popularity, way before things like libfuzzer or AFLFuzz became available. So at Mozilla, it was always the case since I've joined the company, and even years before that fuzzing was used for testing. And developers readily embraced it because it gave them the test cases they were looking for, rather than like having to reproduce things from web pages in the wild, for example, which are terrible test cases because they have tons of dependencies and they change, and it's difficult to reproduce maybe. So that's why I think fuzzing was readily accepted. And it was also necessary because we have very, very complex inner workings where we are exposing these inner workings to the web, to untrusted inputs. Think of JavaScript engines, for example, very, very complicated things that require very specialized testing. So doing that without fuzzing is simply not possible. But I can see that browser companies were special at the time when I joined Mozilla. That is over 13 years ago. And then fuzzing became more broadly available when coverage-guided fuzzing became available to the public.
That's yeah, that's great to hear. Yeah, it's certainly important that at least the browsers are leading the front edge there with testing strategy. So for the next topic, I'd like to kind of discuss manual efforts through manual testing versus automated testing efforts. I'd like all three of you to kind of chime in here and maybe have a bit of banter. Khalid, I'll come back to you first, and then maybe we hand it over to Sheikh. But remove yourself from the bias you might have a little bit with CI and what you just you launched here today and developed with Spark. But more broadly, what are you seeing within the recent developments or lack of developments with artificial intelligence, large language models, and how that's impacting today's testing landscape? So yeah, I'd be interested for all three of your thoughts here.
So from a problem statements, what we hear across the board is the automation. So the more automation is needed, and AI or LLMs seem to be one way to do that. And so there are some like changes or recent developments both in the security research community and also in the industry that I can mention. So for example, you see from the security communities that there was the recent AI Cyber Challenge by DARPA, where teams were tasked of using LLMs to try to automatically identify and even fix bugs. There's even from Google Project Zero, so the Big Sleep project, where they also try to leverage LLMs in an agentic manner and uncovered a bug in SQLite. And even in a research paper, where LLMs, they use it to generate use cases for where fuzzing would get stuck when fuzzing like known network protocols where the fuzzer to sort of know the specification for. So these are like first effort, I would say, to leverage this technology. From a more like a business or industry point of view, people are starting to experimenting with LLMs, and so one like nice feedback that when we first started experimenting with Spark with customers, that even if at the beginning the quality of the fuzz tests were not like ideal, but it helped the user to some brainstorm with it a little bit, just to see how a fuzz test would look like, or what's the different strategies you can see. So these are like encouraging, I would say, developments and also in the research community, but so the capabilities are increasing. So I'm hopeful of a more impact.
Sheikh, maybe over to you.
Yes, I mean I would say I'm definitely with Khaled regarding where AI or LLM can be used. The main issue here would be the domain knowledge. I mean, in the IT world, probably it's probably would be easier to get. I'm not saying too easy, but easier to get using AI to solve, fuzzing related automation more easier than automotive. In automotive, there are the problem is the domain is so diverse. So you have the various hardware architectures. You do have the issue of software and hardware dependencies, very diverse and complex tool and build chains, for example. And so the agents or the LLMs or the language models should be able to learn this. So the thing is, if you're not using it, if you're not having a base LLMs that is able to do those things, it will be very difficult to try it in those specific domains. So therefore, I mean, um, especially in the automotive, when we are using LLMs in house, we can start from there basically to see how we can train those models. But then, yeah, I would say I see that the AI can definitely help in writing harnesses automatically, focusing on the code structure. But here I also kind of a skeptic how AI agents will be, handling the multi-thread programming where multiple threads will run in parallel, and which one to choose, and prioritize them. So there are many different challenges still, but I mean, I'm hopeful that it will be also solved. But I mean, there should be specific LLMs that can help us keeping into that domain, keeping us advanced in this domain. That I believe.
Christian, how about you guys? What are your thoughts?
Yeah, I have very similar thoughts. So we're actually not using LLMs in production yet for fuzzing. Of course, we're experimenting with it across the board, like for fuzzing, for security analysis. We have lots of ideas that we want to experiment with. And I have one particular thing in mind where I think AI could be very helpful in the future, and it's again related to automation. So at Mozilla, we have a lot of specialized fuzzers. What I would call high knowledge fuzzers. So coverage guided fuzzing can only get you so far when you have very, very complex targets. Think of, for example, of the WebAssembly engine in a JavaScript engine. There's a 200-page specification on that. It keeps changing all of the time. We do have coverage guided fuzzing to test these parts of the code, and they find bugs. But you do not achieve the code coverage that you would like to achieve only by doing that. You also need to encode knowledge from that specification into the fuzzer. And you can do that. You can let an engineer spend time on that, and then you have this fuzzer. But the specification keeps being extended and changed all the time. So you have this constant maintenance where you have to pick up new features from the specification and implement them in your high knowledge fuzzer. And I can see that we could maybe automate this. We could use AI to read through that specification and translate it into changes for these high knowledge fuzzers. That is, for example, something that I would find very valuable. It would make sure that we are always sticking to the newest features in the specification as well, which are also usually the most risky ones because they are new code and they are the least tested. So we also want to be fast in doing that. And given that the web becomes more and more complex and specifications become longer, it makes sense to try and automate and scale that process.
Sure. So we had a question in the Q&A section that I think is, well, I'm interested to get your perspective first, Christian, would be, how does an organization like yours consider, let's say, the IP guarantee or the confidentiality guarantee as you guys start to experiment with LLMs? And what are some of the things that you're looking for before you make a decision to do something in production?
So that is actually not something where I can say a lot about. Of course, we have our internal legal processes to ensure that we are legally and contractually covered. In general, I can say that when we internally use tools from third parties, we have rigorous processes to ensure that everything we are sending to these parties, even if it's just internal testing data, is actually well protected by legal means, by contracts, and so on. And I believe that that can also be done for LLMs. On the other hand, for LLMs, you can also try to basically have your own infrastructure that uses certain open source LLMs, for example, if that is a concern to you. And we're also experimenting with that. I mean, we are an open source company. It would be really nice if we could use open source LLMs for our purposes. And in fact, we have invested significant amounts of work into making open source LLMs more usable, Mozilla as a company.
Khaled, what are you seeing on this front? So obviously you're using LLMs as we develop Spark. You're testing a bunch of the open models out there, but maybe you could even connect it to Shake's world, where you have a massive automotive company like Continental. They want to experiment and start looking at the capabilities of the efficiencies they can gain. How do you have that conversation? What are some of the options that you're kind of bringing to light for some of these companies?
Yeah, so so far, the way we sort of design Spark is not to have a dependency on a certain LLM, because different customer, different user would have their own LLMs. So we need to be able to handle this. And if you're really because you're really worried about IP, then I think the best maybe option would be legally for you just to use an open source LLM. And yeah, like if you've been following the news like lately, open source LLMs tend to be quite good, and even with smaller size models. So if this is sufficient for your case, then this is great. And one thing regarding so the sort of the experimental approaches that I mentioned earlier they all were tested with open source software. And so one issue there is that you then need to assume that the LLM of the model has seen the code base that you're trying to test in their training set. So if I tell it, give me a fuzz test for function for X, then I need to assume that that it has seen this code somewhere, or it knows what OpenSSL, for example, is. What you want to apply the solution is for closed source, so that you need to be really careful about which context you then need to take or use from the source code in order for the LLM to have enough information and context to create realistic or correct fuzz tests. So far, this has been working very nicely. But I can imagine that for certain use cases where you have really domain-specific domain knowledge that you need or specific characteristics, you would then need, if you already have your open source LLM, then maybe fine-tune it a little bit to your use case, and then this would significantly improve the results that you would get.
Shake, does that translate well for an organization like Continental, as you guys are looking to? I mean, you're in the innovation department, right? So you're on the cutting edge of trying to bridge this gap. Is that the approach that an organization like yours is open to?
Yes, I mean, we are definitely I also agree with Khaled that the open source LLMs, if they can be trained locally and then make it customizable, I would say inside the company for the legal issues and so on, that is a lot of promises. I'd say not only for cybersecurity purposes, but many other different domains to increase the efficiency of different processes and so on, that we can make use for. I mean, so definitely, I mean, that's the way to do. And I think it's it's a software-defined vehicle era, and a lot of suppliers, I would say, and also OEMs, they are joining Eclipse Foundation to make it open source, and then more and more suppliers also partially going open source with different Linux kernels and so on. So therefore, I would say, I mean, the automotive industry has also stepped up to collaborate with each other, to have common code base to develop on the top of that the proprietary solutions. And I see that in the future there will be more and more innovation coming on the top as automotive stakeholders are going open source. So I think everyone will benefit with that. So that's what I see the trend. So I'm pretty hopeful, I would say.
Makes sense. Well, gentlemen, we're pushing up against time here. Christian, I wanted to, maybe you'll end us here with the closing thought, because in our conversation that we had a couple of days ago, you brought up this idea of parallelizing fuzzing to sustainability, and how these two are actually interlinked, which I thought was a fascinating comparison you made, and it's obviously very relevant as we're hearing about new large language models coming out, using less energy, needing less GPUs. Perhaps, I guess, how do you think about fuzzing when it comes to a sustainable testing approach, and how does that make sense to you?
Yeah, I mean, we always have to think about like the environmental impact whenever we come up with new testing methods. And in particular, LLMs can be quite heavy in terms of like energy consumption and impact, but that doesn't necessarily mean that we can't use them. We have to basically balance that against what we get from it. What I would basically recommend is we should try to utilize LLMs in such a way that we get from one time effort, we get a lot of result out of it. So basically generating a fuzzer from an LLM is actually a great idea. You're investing energy once to create a fuzzer that can run for a very long time, spending much less energy compared to like continuous use of an LLM that consumes a lot of energy again and again to analyze particular code. So we always have to balance these. And we also try to do that at Mozilla. We always think about like what is the impact? Do we actually need to spend these many CPU cycles on testing this and that, based on like code churn and how many bugs are falling out of this and code coverage? And we're trying to balance that. And we're also doing that with the LLM experiments that we're doing right now. So for example, I would be less inclined to use a continuous LLM approach to, for example, generate inputs for fuzzing. I would rather try to let the LLM generate the generator in order to save some energy.
Yeah. Yeah, I completely agree, and I think that is one of the really attractive points on this journey that Khaled and the team are going down with Spark. The LLM portion is really to create that fuzz test, that fuzz harness, and then you get a lot of benefits that you get from the actual fuzz test because you don't need the LLM component for actually running the fuzzer. Awesome. Well, a really fascinating discussion today, guys. Thank you for taking the time to be with us. I genuinely appreciate it. And yeah, I hope you guys will stick around for our last session with Nicholas. But we're super appreciative to have you on and for being great partners. So thank you all, and I hope you have a fantastic day. All right. So we now will be moving on to our last session. So if you're still with us today, thank you. I hope you enjoyed the discussion. Before I hand it over to Nicholas, I will be launching our last poll, which will be very relevant to this next conversation. So from a CI/CD perspective, where would automated fuzz testing make the most sense for your teams? Do you want it locally in the IDE, similar to maybe what you saw with Khaled today? Does it make sense to have in the CI/CD pipeline? Potentially both, but very curious to get our participants' views on this. And we have quite a few questions in the Q&A section. Really good questions. So a lot of them way too technical for my capabilities. So Khaled, I may ask you during Nicholas's session, if you have the ability to go in and answer some of those questions in text, that's great. If not, we're going to, again, please upvote the ones that you think are the most relevant, and we will be answering these live after Nicholas's session. All right, let's end the poll and share the results. Nicholas, let's see here. Let's see what we're looking at. So I think most of our participants here are ready for the future, right? So let's get this out of the IDE, put it in the CI/CD pipeline. How does this line up with your expectations?
Yeah, that's super cool to see. So I like that people want to integrate fuzzing all across the software development lifecycle. So being it locally in the IDE or even with every pull request in the CI/CD pipeline. So that's great to see. That's great to see.
Awesome. All right, over to you, Nicholas, and please take us on a journey into the future. What are we excited about?
Yeah, thank you very much, Tai. Yeah, I'm going to show you what's in store for 2025, what we have planned. But before doing this, let's take a quick step back and recap what we have already achieved with our AI test agent. So the AI test agent helps you with setting up fuzzing across all stages of your development lifecycle, being it locally or in the CI/CD pipeline. As we have seen, it helps you generate fuzz tests automatically with the help of LLMs, and it helps you then assessing the results of the fuzz tests. So it helps you to reproduce findings, and it even helps you fixing the findings. It helps you with debugging workflow. It helps you a lot with having insights into your root cause for easy remediation, and helps you with actually fixing the findings. But let's see if we can even take it a step further. If we take a look at how findings or bugs are actually handled in company processes, well, the picture might not look that good, because most of the time, a lot of bugs are collected, but it might take some time until they are actually fixed, because the bugs need to be discussed across different stakeholders across the company. So different departments need to be involved, different persona, project managers, developers, security experts, all need to be brought to a table and to discuss, okay, how to proceed with these bugs. And yeah, if a decision has been made, it might also take some time until the fix or whatever makes it into the sprint, whatever release cycle you may have, until it is finally fixed. But here at Code Intelligence, we want to change this and help getting more bugs fixed, because if we take a look, we can already automatically find bugs with the help of the AI test agent. Khaled has already demonstrated how to do this. But the next step would be that we can also automatically fix bugs. And even taking this one step further and even prove that the fix is correct. I know many of you may think, okay, automatic fixing bugs, you're not the only company trying to do this. That's correct. So there are many security companies out there that are trying to automatically fix the findings they have. But I think we have one unique advantage, a very, very unique advantage, and this is the power of fuzzing in and of itself. And the next few slides, I'm going to show you how we plan to use the power of fuzzing to actually generate valid fixes for a bug and even prove that the fix is correct. If we see what fuzzing, if it has found a finding, produces as extra information, there's a lot to it, which helps you understand the root cause and see what's going on. For example, right now, with the AI test agent, you already get the exact location of the finding. You get the crashing input. So what is the input you need to feed to the system in order to reproduce the finding? And you also get the stack trace, meaning the path through the maze of your code, which the input needed to take until it has triggered the vulnerability or or the finding. So this is very valuable information already. So exact location, crashing input, and the stack trace. And with fuzzing, we also have the advantage that we also have a reproducible setup. So that's the Fuzz test. So this was where all the magic about the AI test agent is all about. So as Christian put it so very well in the panelist discussion, so basically the generator, yeah, so the generator which generates and the input. So basically this is the reproducible setup we have. So we can check with this setup if given a crashing input, the vulnerability still occurs. And we can combine this information. So we can use this information, the stack trace, the crashing input, the reproducible setup, and the exact location, and combine it with a root cause analysis to understand, okay, what's the root cause of this finding, and also then create a patch and verify that the patch is working. And all of this then leads to a change, which you can apply to your source code in order to fix the vulnerability which has been discovered by fuzzing. So this is in and of itself already super cool. So we will spend less time in discussing it, and because we have the fix already available. So there's no need about lengthy discussions. Shall we fix this or shall we not? The fix is already there. You just have to apply it. And we will make even this easier because we can prove that the fix is actually working. So this also is due to the superpower of fuzzing, because we can apply the fix to the system under test. We can replay the crashing input to the system under test and just check if the crash occurs. So if it doesn't occur, we know that the proof, we know that the fix, fixed the bug and have proven that the fix is working. But you will also, or may ask yourself, well, changing a system, there might also be other consequences, but we can check for those as well. So with the help of fuzzing, we can, with the fix applied, we can even fuzz some more. So we can check that no additional side effects were introduced by applying the fix. So if we apply the fix, fuzz more, we can check that nothing else breaks. So that, for instance, we didn't introduce another vulnerability by applying the fix. So this is something that we can do due to the superpower of fuzzing. We have all the information available, and we can combine this to extract the fix and check and prove that the fix is working in your system. But still, we want to make sure that the final say is with the human individual. So the workflow shall be integrated right into your code repository, into your GitHub, GitLab, whatever you may use. But for the first time ever, fixing a bug can also be done by a non-developer, because merging a pull request or applying a fix to the system does not need to be then done by a developer, because we've already proven that the fix solves the problem and does not introduce any side effects. So this is great. So we can also involve other stakeholders from your company and help with fixing bugs in your system. So then moving on, how shall this look like? So I'm going to share my screen now and show you how we have envisioned this to look like. So we have here, what you see right now is GitHub. And here you can already see a security alert, which was already found by our AI test agent. So we have, which is possible as of now, you can already integrate the AI test agent in your CI/CD pipeline, and we will generate those reports here for you, and you can already see the information I've already mentioned before. For example, here we see the offending line, so where the vulnerability has been found, the crashing input, and also the stack trace, so the path through the system. So this is the information I've talked about. And we're now going to use this information to actually generate a pull request. A pull request automatically generated, which fixes the issue. So this is super, super helpful. So you can, in the end, you just need to merge this pull request and be sure that the change fixes your bug and no side effects were introduced. So we can have a look at the change. So this is a very simple fix here. So we can see that this will help remediate the issue. And now everybody in your company can just merge the pull request and the bug is gone. So this is something that we envision for this year to work on and to put into reality. So coming back to the slide to recap. So what we can already do is automatically find bugs with the help of the AI test agent, what we have already seen. And the next step for us is to automatically fix those bugs and even prove that the fix is correct. So really exciting times ahead. And with that, over to Ty. Thank you very much.
Thank you, Nicholas. Yeah, nothing else to say other than indeed exciting times to come. The idea that we can start from fuzzing, automating that, moving into remediating, automatically proving it's quite the feat. But thank you for walking us through that. Okay, so on time, we're on time, we're doing good, which is great. So at this point, we will move into our Q&A session before we then end with Eric and closing remarks. There is quite a few questions coming through. So again, we really appreciate the interaction that we've seen so far. I'm going to go ahead and refresh this to the most upvoted. And Khaled, I'm already going to warn you. I'm going to need you here, so you can definitely come off camera. And let's see. So
I try my best to answer some of them, but
yeah, if we're not able to get to all of them, we will write to you. We'll try to get in touch with you individually to handle those. So the most upvoted one here we have is when you running the same session regarding Spark, when you run the same session again, will you get 100% of the same results in test cases, or will you see some variations due to the AI?
So you would see some variations, but not only due to AI. So first, the answer that you get from the LLM varies with different invocations, and that's why we employ sort of a more elaborate strategies to make sure that we get the best answer possible from the LLM by, for example, sampling multiple answers. And you also have another non-deterministic component, which is fuzz testing. If you start the same source code, the same fuzz test for the same amount of time, you would get variance in the code coverage that you get. So that's what I mentioned. So sometimes for some demos you get 5 fuzz tests, sometimes you get 3 fuzz tests, depending on like how quickly you reach the coverage goal. So you wouldn't get the same result.
Okay. And on the topic of scale, so one of our attendees asked, how well does your solution scale with the size of the code base?
So the part where we try to identify the best candidates or to fuzz, this is based on static and code analysis. So basically need to parse the code, build the abstract syntax tree, build the call graph to be able to make sense of what's happening there. So this is so it would be slower with larger, understandably, with larger code bases. But I think we tested with code bases with several millions of lines of code, and and also, for example, the Wolf SSL is roughly 1 million lines of code. So it's quite a large code base. So you would need to, it would take a little bit longer. And just it goes with the size of the code base.
Okay. Regarding the types of vulnerabilities or bugs or quality issues that we find with, I'd say, fuzzing in general, one of our attendees asked, what are the types of vulnerabilities that you see coming up when you do run Spark and or fuzzing? So are they OWASP related? Are they other standards? Could you maybe walk us through some of the types of vulnerabilities found?
So this is a question that I wouldn't say it's like special to Spark, but this is in general fuzz testing. And so, like, if you're talking about C++, so by far the majority of bugs that we found in fuzz testing are like memory corruption bugs, buffer overflows, use after free, double free, stuff like that. And you can also, if you do you can use also Fuzzing to get to find some quality and or functional testing by, like, for example, property-based testing or property-based fuzzing. For other languages, for example, in Jazza, we do have our own bug detectors, like to detect things like remote code executions or SQL injection. But this is, the types of bugs are sort of specific to the language that you're targeting. But for C++, memory corruptions are by far the biggest.
Eric, I might have you jump in here. So we have one question asking around when, so I guess when is the automated remediation going to be available? So I think maybe a little confusion. They saw Spark, obviously very excited, but we did talk about something very intriguing. Maybe would you walk us through, from your perspective, when are these things going to be available?
Yeah, 100%. And I love that question because it also helps me internally to push Niklas, Khaled, and the team a little bit. So that's always good. So thanks for the interest. So the remediation feature is something we'll be focusing on in 2025. The idea is to have, let's say, a test version out in the market to start testing with, let's say, some of our partners and customers in early H2. So then to basically have it fully market ready and ready for the official launch in Q4 this year. The good thing, however, is that on the remediation side, given that the AI test agent already provides the sec traces, the crashing inputs, and the exact location, it already makes your life remediating the issues that you find a lot easier compared to other approaches. So let's say the remediation itself is not there yet, but the current product as it launches today already provides you with a basis of doing so more effectively compared to the SS.
Okay. And don't leave yet, but I need you and Niklas for this next one. So Niklas, maybe you'll come back on. I think you may have voted yourself to answer or help answer this question. So we have a question from Michael saying, does Spark mainly work for web-like libraries like YAML, OpenSSL, etc.? So that's kind of the first question. And then the second question, which I think maybe Eric, you'll jump in as well, is this topic of classic AutoSAR. So for our automotive attendees here, I think we have quite a few. How does this interplay with AutoSAR? And maybe you could also highlight on what are some of the things that we do around AutoSAR. Niklas, but perhaps we'll start with you.
I would say that fuzzing is in and of itself not particularly limited to some use cases. So there are certain things that work quite so even better with fuzzing, but I wouldn't say that there's a limit to what you can test. Whenever your software is testable, I would say that it's applicable and that you can use the AI test agent to test your software and gain more insights about how your system behaves when random input is fed to the system.
And Eric, so if we do have someone here in the crowd today who's interested in testing a classic AutoSAR type application, I see some comments there around Ethernet, CAN, etc. Maybe you'll walk us through what are some of the things that we can do to help those customers.
Yeah, 100%. I mean, the issue typically, let's say with this type of code is that you need to be able to test in the first place, right? And you still have a lot of hardware dependencies there that are, without any, let's say, proper help on the software side, difficult to test without having the hardware present, right? And I think I listened to a Conti talk actually in December last year that talked about virtualization of the testing process or of, let's say, SDV process in general. And I think for me, that really hits nail here. And how we can help with that is not to just basically employ fuzzing, but we also do offer an AutoSAR simulator that basically mocks all those hardware interfaces and allows you to test your code without needing to have the hardware in place. So it's a separate, let's say, a separate part of our offering, but I think why we developed this, because we saw that exactly this issue kept on arising a lot, that hey, we'd love to use fuzzing, but it's difficult to do so at scale because the hardware dependencies always come into play. And this is why the AutoSAR simulator helps with that and also allows customers who do still have those hardware dependencies to use fuzzing at scale without the hardware needing to be there.
Thank you, sir. Khaled, I might have, and I think I'm just going to try to answer as many of these questions as possible as we do have the time. Khalid, I'll bring you back in for this one. So the question is, if I understand correctly, does Spark automatically generate fuzz targets to increase coverage? So that's kind of the part A of the question. And then what is it using in the background? So libfuzzer, AFL, how does that intertwine within the world of Spark?
Yeah, so the first question is easy to answer. It's yes. So this is such a main component of Spark being able to automatically generating fuzz tests or fuzz harnesses, ensuring that we can actually compile and run those one, and that they are of high quality. And so under the hood, we mainly leverage libfuzzer and AFL++.
That's great. And then if you you went away too quick, I have one last question for you. There's quite a few top questions around compilers. Now, I think it's a natural question. So I'll try to summarize it, but maybe can you talk about this potential complexity introduced by compilers? How do we handle it today? How do you, as a fuzzing expert, kind of recommend organizations to think about implementing fuzzing and what you might need to think about as far as compiling the code?
Yeah, so the main compiler we work with and we recommend to customer is CLang. So for example, libfuzzer is part of the LLVM project. So CLang is one main compiler that we use. GCC is also available. And for example, if you have certain issues where your code cannot be built with CLang, or we saw this issues where it was not that straightforward just to make the code base compatible with CLang, and GCC was the alternative, for example. And then for these cases, we would use, for example, AFL++ under the hood. We usually have the case like for when we target embedded and automotive software, is that usually these projects are meant to be run on the target hardware, which we then use specialized compilers, for example, like Green Hills. So what we do there is also for these projects, make them compatible or run with CLang or GCC, and this is obviously the main approach we follow.
Okay, very good. And I will take one more question. Well, I'll answer one, and then because I see this is coming up a lot, and I think we're having some participants answer about it, and then I'll bring back Eric for one last question, then we can move into closing comments. So the question around confidentiality, IP, large language models, putting your proprietary information. As a general disclaimer, so Code Intelligence, our offering is a on-prem solution. So we do not host our white box fuzzer, Spark, anything like that in the cloud. So we don't receive your source code. Obviously, you're using the fuzzing technology locally on your infrastructure, on your work machines. So all of that IP confidentiality concern is certainly enclosed within your organization and very secure to use. Eric, last question, not to put you on the hot seat, but I can't ignore the language support question. So it's coming in. I think it's a natural one. They saw a lot of C++ being talked about today. But yeah, maybe I'll hand that last question over to you and then allow you to move into closing remarks.
Yeah, 100%. Thank you. And yes, 100% valid question. So, I mean, long story short, we do want to start where it hurts the most, right? And in our experience, the memory unsafe languages such as C and C++ as well is where the pain is the highest. So this is why currently the key focus is on supporting those two languages. And then we'll basically be moving into other languages going forward. We've already started dipping our toes in Java and JS, and then other languages such as Go, Python, Rust down the line will be logical consequence. But we want to make sure that, first of all, we do have the end-to-end workflow properly defined and understood including remediation for CC++. So this is our strategic priority right now. This is what, let's say, 95% of our customer base currently is using and is basically requiring support for. But obviously, this is just step one of the journey, and there is a lot more ground to be covered, which we'll be getting to later this year and then next year as well.
Thank you, sir. And I should note before I leave officially, any questions that we have remaining, our team in the background, we will write down your name, your question, and we'll be sure to get back with you on an individual basis. But due to time, I'll allow Eric to move into closing comments. Thank you all for having me. Thank you for listening to me. It was a pleasure and a fascinating event. Eric, over to you, sir, to close us out.
Thank you, Ty, and thanks for moderating today. Thank you to all of you for coming in today, for listening in. I think quite a few interesting insights. I mean, I personally obviously loved the demo session, but in all honesty, I had seen it a few times before. So the panel for me was a personal highlight. So thanks, Christian, thanks, Jake, for joining. I mean, talking about the actionability of actual fuzzing results, about different departments currently needing to come together to actually also provide the necessary domain knowledge, something that we do try to address with Spark, with our AI test agent going forward, to just facilitate that process and just have people focus on their core job responsibility and trying to take away as much manual effort from them as we possibly can. I do also want to thank, most of all, our team at Code Intelligence, obviously, focusing on the team behind the scenes, really, Rita and Natalia, who put everything together today. Thank you for setting this up. This was a lot of fun for me. I do hope there was a lot of fun for all of our participants as well. Thanks, everyone, for joining. Thanks for your interest in what we do at Code Intelligence, in fuzzing forward. And we'll be sure to be in touch. We'd love to hear more from you if there are any comments, feedbacks, any, let's say, anything that resonate or did not resonate. That's also perfectly fine. Please let us know. We'd love to hear from you. We're looking forward to engaging more. Thanks to your partner, to our partners, to our customers for joining today, and very much looking forward to continuing this great journey with all of you. With that, I'll give you some time back. Thank you, everyone. Have a great afternoon. Have a great rest of the day, a good night, depending on where you're dialing in from. So looking forward to engaging with you down the line. Thank you and goodbye.